the massive volcanic blast last year in Tonga in the Pacific. It was felt 18,000 kilometers away.
A huge volcanic eruption off the coast of Tonga in January.
Jaw-dropping images of an extraordinarily powerful and now deadly volcano erupting in the Pacific Ocean.
If you look at this map of the South Pacific Ocean, you will see Tonga in green. It is an archipelago that consists of 169 islands, with 3 main island groups: Tongatapu, shown in red now, Ha'apai in blue, and Vava'u in yellow. The capital, Nuku'alofa, is located on the island of Tongatapu. The islands are surrounded by coral reefs, and the waters are home to a diverse range of marine life. One of the most notable geological features in Tonga is the Hunga Tonga-Hunga Ha'apai volcano, which erupted in 2015 and created a new island. This island is located between the islands of Hunga Tonga and Hunga Ha'apai and is visible from space. Nestled within the tumultuous Kermadec-Tonga subduction zone and its fiery volcanic arch, Hunga Tonga-Hunga Ha'apai stands precariously just 100 kilometers above an incredibly active seismic zone. For decades, scientists and volcanologists worldwide have been holding their breath, knowing that this unstable region could unleash disaster at any moment. And now their greatest fear has been realized, as the Tonga volcano erupts with a vengeance, fracturing the earth beneath our feet. With memories of the massive eruption that shook the world just a year ago still fresh in our minds, it's no wonder that the worry and speculation about this latest disaster are justified. Rising from the seafloor over 2,000 meters tall, this colossal volcano is a force to be reckoned with. Its caldera, which is approximately 150 meters below sea level, measured 4 kilometers at its widest extent just before the 2022 eruption. The Hunga Tonga-Hunga Ha'apai volcano, part of the Kermadec-Tonga Ridge, forms a long chain of islands and volcanoes as the Pacific Plate collides with the Indo-Australian Plate. Although mostly underwater, the Hunga Tonga-Hunga Ha'apai Islands offer a glimpse into the volcano's past. They're the last remnants of the caldera's northern and western rim, which stretches around 20 kilometers in diameter. The volcano's northern and southern regions were already filled with deposits from past eruptions before last year's explosion. The 2 subaerial islands were once 1.6 kilometers apart, but are now united by a new land bridge that was created during the 2022 eruption. They were composed mainly of andesite and layered tephra deposits with steep rocky cliffs. Samples taken from the islands show a long history of eruptions, with one pyroclastic flow dating back to 1040 to 1180 CE. This eruption correlated with a tropical eruption in 1108 CE that caused 1 degree Celsius of global cooling and formed the caldera. Experts have a healthy respect for this incredible geological phenomenon, and for good reason. In the wake of the 2015 eruption, Hunga Tonga Island moved closer to Hunga Ha'apai through a wide tombolo, while sandy deposits also filled up the southern end of the crater's link with Hunga Ha'apai. Meanwhile, erosion in the southeast created an opening that flooded the crater and eventually formed a lagoon. This volatile volcano has been active for years and erupted multiple times in the 21st century. In 2009, a submarine eruption sent pumice, ash, smoke and lava spewing into the air, forming a new land surface. The eruption also coated the once lush Hunga Ha'apai Island with thick ash, killing off all the vegetation and fauna. Another eruption in 2014 caused volcanic plumes and earthquakes to rattle the volcanoes north of Tonga. This led to the start of a new eruption in mid-December, with a white steam plume rising from the ocean over the volcanic mount. The eruption continued in 2015, with a massive ash cloud towering 3 kilometers into the sky. By January, the volcano was spewing ash plumes 9 kilometers high, which then gradually reduced. By the end of the month, the Tongan officials declared the eruption had ended. In June of 2017, 2 intrepid French explorers ventured onto New Island, capturing rare photographs and collecting rock samples that would later be used by NASA scientists as a model for volcanic shapes on Mars. But little did they know that their collection of 16 rock samples would reveal something fascinating about the volcanic ash that makes up much of the Hunga Tonga-Hunga Ha'apai Island. The ash had reacted with warm oceanic water in the past, transforming into a much harder rock that could last for decades. Or so they thought, until the unforeseen eruption of 2022 came along and decimated the island. The 2022 Hunga Tonga-Hunga Ha'apai eruption was a record-breaking event in several surprising ways. The volcano spewed out a large plume that was visible from Tonga's capital and unleashed a blast that could even be heard as far away as Alaska, 6,000 miles away. It took around 4 weeks for the eruption to reach its peak, which scientists described as a magma hammer, rated at least VEI 5 on the Volcanic Explosivity Index. This eruption displaced around 10 cubic kilometers of rock, ash and sediment, and set off tsunamis across the Pacific Rim. The effects of the eruption were felt in several countries, with New Zealand, Japan, the United States, Chile, Peru, and the Russian Far East being the most heavily hit. According to NASA, it was 100 times more powerful than the atomic bomb dropped on Hiroshima, making it the largest atmospheric explosion recorded by modern instrumentation. This eruption was also the largest one since the 1991 Mount Pinatubo eruption and the most powerful one since the 1883 eruption of Krakatoa. The eruption was so powerful that it released a plume of gas and ash high enough to touch outer space, which is a unique observation for a terrestrial volcano. Recent surveys of the seafloor conducted by a team of scientists suggest that the eruption excavated an enormous 2.3 cubic miles of rock. What's more, the explosion also injected a record-breaking amount of water vapor into the atmosphere, which has the potential to upset the global climate. The tsunami it caused was equally bewildering, and satellite images revealed just how powerful the blast was. Despite its incredible power, scientists are still studying the eruption and trying to understand the dynamics of pyroclastic flows underwater. In a recent survey, scientists mapped out an area surrounding the volcano, revealing evidence of multiple pyroclastic flows radiating around the caldera. The findings suggest that the pyroclastic flows were deadly and fast-moving, leaving an eerie white layer of fine sediments in their wake. These events remind us that we still have much to learn about the giants of our planet, and we must always be respectful of nature's power. The volcanic flows also caused the disruption of communication lines within and outside Tonga, impeding the recovery efforts in the area. A model conducted by Emily Lane indicated that the volcanic material flowed into a valley and hit the walls, breaking a communication cable and dragging it northward. The research also revealed that the eruption excavated 2,300 feet of rock in the central crater, with 75% of the debris falling within 12 miles of the volcano, and the rest circulating in the air as dust for months. This dust led to spectacularly vibrant sunrises and sunsets. Although the volcano was still active and emitting hot water mixed with volcanic glass, experts believe that another massive eruption is unlikely to occur in the near future. Scientists are still analysing the aftermath of the Hunga Tonga-Hunga Ha'apai eruption, and new research by Oxford University reveals that the explosion in January 2022 created the tallest volcanic plume ever recorded, reaching an incredible 57 kilometres high. The ash cloud generated by the eruption made history by being the first one to be observed in the mesosphere, which is the layer of atmosphere that is typically associated with shooting stars. The previous record was set in 1991 by the Mount Pinatubo eruption in the Philippines, which caused a plume that reached 40 kilometers. Japan's Himawari 8 satellite has captured images of the incredible event, and experts have noted that the eruption put a significant amount of water into the normally dry mesosphere, making it an important case study for testing climate and weather models under extreme conditions. Scientists are also warning that the underwater eruption of Hunga Tonga-Hunga Ha'apai may have a global impact, possibly causing a temporary increase in global surface temperatures over the next 5 years. Typically, volcanic eruptions cool the planet temporarily, but the Tonga eruption was different. It expelled a lot of water into the atmosphere, which, being a greenhouse gas, could cause temperatures to rise. The new study found that there was a 50-50 chance that global temperatures would exceed 1.5 degrees Celsius above pre-industrial levels at least once by 2026. However, the aftermath of the Hunga Tonga-Hunga Ha'apai eruption has increased the likelihood of this happening by 7 percentage points. although crossing the 1.5 degrees Celsius mark temporarily will not mean missing the Paris Agreement target, the authors say that it will attract substantial media attention, even if a portion of this increase results from the Tonga eruption. Whenever a volcano erupts, it usually causes a drop in global temperatures due to the plumes of dust and aerosol reflecting sunlight away from the planet. However, the eruption of Hunga Tonga-Hunga Ha'apai had an unusual effect. In fact, it caused surface warming due to the unique composition of the volcanic plume. Dr. Stuart Jenkins from the University of Oxford's Department of Atmospheric and Planetary Physics explains that the blast expelled significantly less cooling sulfur dioxide aerosols into the stratosphere as compared to the amount of water vapor that was propelled, 146 million tons, which raised the water content in the stratosphere by 10 to 15%. The eruption was so huge that even astronauts aboard the International Space Station, 269 miles above the Pacific Ocean, witnessed the volcanic plume. The power of the Hunga Tonga-Hunga Ha'apai eruption was so great that it disrupted the Earth's atmosphere in ways that were previously unseen. Scientists noted that the disturbance to the ionosphere, caused by the release of energy, was comparable to that of a solar geomagnetic storm. Even NASA's Global Ultraviolet Imager, which is only designed to scan areas 100 kilometers above sea level, picked up on something unusual in the far ultraviolet light spectrum. A temporary recession in UV emissions, corresponding with the volcano's location, suggested that water vapor from the eruption had reached an unprecedented height, possibly beyond the mesosphere. Moreover, the eruption also generated an astounding amount of lightning, with over 25,000 lightning events detected in just 5 minutes, and an incredible 400,000 lightning events over 6 hours. Meteorologist Chris Vagaski commented that it was the most concentrated amount of lightning ever recorded. Dr. Shane Cronin, a professor of earth sciences, revealed that his team found evidence of regular, massive eruptions occurring every 1,000 years, with the last one happening in 1100. The deposits from this volcano indicate there may be more eruptions to come, with the possibility of even larger and more frequent eruptions in the future. Let's hear what you think about this giant underwater volcano in the comments below.